about the supervised learning in machine learning. Okay. Introduction to the machine learning. First of all, we will see machine learning is a branch of artificial intelligence that enables the computer to learn from the data, and improve the performance without a being explicit. What is meant by the machine learning? Machine learning is the artificial intelligence to powerful tool to introduce the machine learning algorithms for the next data analysis. The computer's learning is a CS branch to start the machine learning artificial intelligence to the performance solving to explicit programs. Okay, this field we will study that give computers to ability to learn without explicit programs. There are the three types of the machine learning we will see in the next. Okay, there are the three types of machine learning. First of all, we will see supervised learning. What is meant by the supervised learning? The supervised learning is a label data. There are the data, they are named and labeling we are provided. Second is the unsupervised learning. Unsupervised learning is called as the unlabeled data. Unlabeled data means the data have no name and unstructured data. And the third one is the reinforcement learning. What is the reinforcement learning? Reinforcement learning is the action and reaction. If you have the action, then the data is react to your reaction. That's why the reinforcement learning we are used. There are the three types we have seen for the machine learning. Okay, we have a this deep description of the machine learning. First of all, is a supervised learning is the most commonly used type of machine learning. In a supervised learning, the model is trained using a label data. That means the input data comes with the correct output. The programming learns the mapping between the input and output. The second one is unsupervised learning. Unsupervised learning is called as unlabeled data. The model tries to find hidden patterns or structure in the data. And the third one is a reinforcement learning. Reinforcement learning is inspired by a behavior psychologist, and agents learn by interacting with an environment and receiving a reward on the penalties. Agents, environment, actions, and rewards. The agents are learning or decision makers. The environments where the agent operators action what the agent can do, and rewards is the feedback from the environment. Okay. In this description, we have seen only what is the supervised learning. First of all, we will see what is the supervised learning. The supervised learning means we have a type of the machine learning and the model trained using a label data. What is meant by the label data and why we are using a supervised learning? To describe the lots of factors. First of all, here are the explanation of the supervised learning, one of the most important and widely used type of machine learning. Supervised learning is a type of machine learning where the model is trained using label data. Each training example contains input data and correct output. The goal of the supervised learning is to learn a mapping function like a y equals to function of x. This means the model runs from the convert input x into the correct output y. Once trained, the model can predict output for a new unseen data. Understanding the concept, let's break it down simply. Imagine a teacher learning students. The teacher gives a question x. The teacher also provides a correct answer y. Students learn from a pattern between questions and answers. In a supervised learning, the algorithms is the student, the trained data is the teacher. The model keeps adjusting itself until it's minimized errors between a predicted output and actual output. Components of the supervised learning input text. It is the independent variables like house size, number of bedroom, email contents, and age of the person. And the second one is the corresponding output is a house y is the depending variables or targeted house price, spam of not spam, this is present or not loan approved. This mapping function we have seen y equals to fx. Fx means the function of the x. We have seen the next one is the Classification. There are the two types of the supervised learning. First is the classification, second is the regression. There are the first is the classification. What is meant by the classification? Why we are using the classification? We are seen in these examples what we are using the classification. The classification variables is the output variables and the categorical variables. Is the predict the class and variables for the data of the classifications. Okay, there we have seen like there are the classification type of supervised learning where output variable is categorical. First of all, then second one is the model prediction is the class label. The examples we have seen the each input is assigned to one of the predefined categorical. In simple word classification answer the question which category does this data belong to. Understand the understand the classification. In input data X is a provide the output Y is a label or categorical Y equals to fx where X is a featured input Y is a categorical label data. There are the examples of the classification email spam detection, spam or not spam, disease diagnosis like a positive or negative, and image recognition is a cat and dog. What is meant by the classification problem? First of all is a binary classification. There are only two classes like spam, not spam, positive, negative, S no, fraud detection. Multi-class classification like a cat, dog, horse, त्याच्यानंतर grade A, B, C, and different types of diseases. Multi-level classifications is the input can belong to multiple classes at the same time. Real world examples is a, like a email spam detection. Input email content, output a spam or not spam used in a Gmail or other email services. Disease diagnosis like a input and medical test result. If output is a positive or negative, help doctors in early detection. And third one is the image class recognition. Like means the cat and dog. Okay, used in a facial recognition. If the categorical classification facial recognition is a cat, then they describe is the object detection system. How to classify work step by step. First of all, collect the data, split into train and test slate, train the classification algorithm, evaluated model performance, and predict a new data. This goal is to minimize classification error. Common classification algorithm. Now let's understand the measure of it. First, how it works, use a sigmoid function, output probability between 0 and 1. If probability 0.5 is a greater than of probability, then the class 1 and else is the class 0. This is the we are using in classification algorithm. The second one is we have seen a common algorithm. The common algorithm first is a logistic, second k nearest labels KNN, third is a decision tree, fourth is a navy bias, and fifth is a support vector machine. We will see in a discuss and deep description of this algorithm. First is the logistic regression. What is meant by the logistic regression? Despite its name, logistic regression is mainly used for the classification, especially in a binary classification. How it works? Use the sigmoid function. Output probability between 0 and 1. If the probability is greater than 0.5, the class 1, else is a class 0. What is meant by the advantage of a logistic regression? Simple, fast, work well for a linearly separated data. Okay. The second one is the k nearest neighbors and KNN. KNN is a simple distance-based algorithm we are used in a classification. How it works? Choose a value of k. We are choosing the value of k. Find the k nearest data points. Then assign the majority of the class. Example, if three nearest neighbors are spam, second one is also spam, and third one is a not spam, then prediction equals to the spam. Why? Because we are using this spam or spam is the two times or not spam is the one time. That's why when we are predicted, the spam is a multiple times, and that's why we are using this spam for the description of the k nearest meaning. Advantages: easy to understand and no training phase. Why we are say it's easy to understand because the k nearest labels are using the lots of times the data is repeated they are selected this data. Disadvantage is slow for the large data. They are not applied for the large data. These are applicable for only the small data because their exclusivity for the only minimal data. The third one is a decision tree. Why we are using the decision tree? First one, decision tree is a split data based on condition. How it's work? Create a tree like structure. Ask yes and no questions. Split data based on features. What is meant by says the yes, no and questions and tree like structure? If we have the roots and the leaves like the simple real world problems we are seeing the any hierarchical order is called as a decision tree. Example, if my age is a greater than 50 is a high risk and else is a low risk for others like diseases. Advantage like easy to interpret handles both numerical and categorical data. The fourth one is a Navy bias. Why we are using a Navy bias? Based on the bias theorem and probability. Features assumption. Features are independent Navy assumption. Applications. Spam detection, text classification, and sentimental analysis. What is meant by spam detection? If we are using a data spamming like a not spam and spam, text classification, if we are using any text like the data text and we are analyzing the text and autocorrection, we are using the Navy bias. Also sentimental analysis. What is meant by sentimental analysis? We will see when we are using a WhatsApp images, when we are emoji, then we are a sentimental analysis. What we are reacting, the images are described what your mood. That is based on we are using a Navy bias algorithm. The Navy bias algorithm's advantages is very fast, work well for the text data. We are using the text data, say we are discussing further in applications, we are using a Navy bias theorem. The last one and the fifth one is a support vector machines SVM. What is mean SVM? SVM is the full form of the support vector machine is the fifth algorithm of the classification. SVM is a try to find the best boundary hyperplane between the classes. How it works? Find a maximum margins between the classes. User support vectors critical data points. Key concept maximize the distance between separating lines and nearest data points. Advantages effective in high dimension spaces. Works well with a small data sets and disadvantages in a computation expenses. Evaluated matrix for the classification we had discussed further. We are seeing the advantages of classification and limitations of classification. We are discussing the advantage like easy to implement, high practical, widely used in industries, work well structured and unstructured data. Limitation of and classification are required to label data can overfit performance dependence on the data quality. Conclusion: classification is a powerful supervised learning technique where the output is a categorical, the model is a predicted class labels, and it is learn the mapping. Y equals to fx like y is a function of the x. It is a play a critical role in email filtering, medical diagnosis, image recognition, and fraud detection. Now we are understanding the classification algorithms like logistic regression, KNN, decision tree, Navy bias, and support vector rules. We will see and discuss about the description about the common algorithm of the classification. We will see the next move on the regression. What is meant by the regression? Why we are using the regression? Okay. The second one class type of the uh, supervised learning is the regression algorithm, and first one is the classification algorithm. What is the regression algorithm? The output variable is a continuous and predict a numerical value. The continuous data is like the range of the data for the uses of the predicted numerical value. Numerical values like integer, float, and other value. We are using this value for the continuous prediction of the numerical data. We are seeing the examples like a house price prediction, temperature forecasting, stock price prediction, and others also algorithm we are using. Okay, We will see the first one is a classification. What is the difference in classification and regression? We will see in a further languages. Okay. The first one is like output variables and continuous. Regression is the one of the most important types of supervised learning. Unlike a classification where the output is a category or a label, regression used when the output variable is a continuous. This means the model is predicted numerical value instead of the class label. In a simple term, regression answers the question how much and what's the number. For example, what will be the price of the house? What will the tomorrow temperature and what will the stock price in a next week? All these examples for we are using the regression. There are not categorical, they are a new numbers. That is why we are using a regression. Understand the regression clearly. In a regression, input x equals to independent variables or a feature. Output is a continuous numerical values. The goal is the learning and mapping the function y equals to fx. This function helps us predict a numerical output for a new unseen data. For example, if x equals to size of the house and y equals to price of the house, the model learns the relationship between size and price after training. If you give it the size of new house, it predicts the price. Okay. The real world example of the regression. Let's understand regression using a practical example. House price prediction. Size of the house, number of the bedrooms, location and age of the house. Output Y. Price of the house. The model studies past house data and predict the price of the new house. Second one is the temperature forecasting. Features is the humidity, wind speed, pressure, past temperature, and data. Output is the future in temperature. Whether a forecasting system use a regression model. The third one is the stock price prediction. Feature historical stock prices, market trends, trading volume, and economics indicator. Output future stock prices. Through a stock market or a complex regression helps identify the trends. How regression works and step by step we will see. Collect the label numerical data, split into a trend and test data. Choose a regression algorithm, train the model, evaluated using error matrices, predict a new numerical value. The model tries to minimize the difference between predict and actual values. Important concept errors in a regression. Since the prediction are a numerical, there will be some difference between actual and predicted value. This difference is called as the error. Common error matrices is a mean square error, root mean square error, mean absolute error, and R to the score. Okay, we will see the common algorithms in the regression. First one is linear. Understand the major regressions like linear regression. Linear regression is the simplest and most fundamental regression algorithm. It is assumed a linear regression between input and output. The equation look like this: y equals to ax plus b, where a equals to slope and b equals to intercept. It tries draw the best straight line that fits the data. Example, if the house price increases steadily with the size line regression work well. Advantages, simple and easy to understand, fast to train, works well for the linear data. What is the limitations of the linear regression? First of all, cannot handle complex and non-linear regression. The second one is the polynomial regression. What is meant by the polynomial regression? In the extension of the linear regression, it is used when the relationship between input and output is not a linear. Instead of the straight line, it's a fit a curve. An example of the question equation: y equals to x square plus bx plus c. It can model more complex relationships. Example, if the stock prices rise and fall in a curve pattern, polynomial regression may be performed a better. Advantages, handle curve relationship more flexible than linear regression, and limitation can overfit easily. Become a complex or a high degree polynomial. Support vector regression SVR. Support vector regression is based on the concept of the support vector machine. Instead of the minimize the data directly, SVR are the tries to detect the lines within a margin of the tolerance. It focuses only on important data points called as the support vectors. Key idea, ignore the small errors within a threshold. Advantages work well with high dimensional data, effective for the complex relationships. Disadvantages is the computationally expensive and harder to turn. The fourth one is a random forest regression. The random forest regression is an advanced and a powerful method. It is used on a multiple decision tree. Instead of using one tree, it builds many trees and averages their prediction. This reduces overfitting and improve accuracy. How it works? Create a multiple decision trees. Each tree predicts a value. Final prediction average all trees prediction. Advantages, high accuracy, handle a non-linear data, reduce overfitting. Disadvantages is the slower than the simple model, less interpreted. Comparison of the regression algorithm. Linear regression, simple linear data, low, moderated. Polynomial regression, curve pattern, medium, and good. SVR is a complex structure data, high complexity and high accuracy. And random forest is a large and complex data set with a medium high complexity and very high accuracy. Application of the regression in the industry. Regression is widely used in a finance, price prediction, and risk analysis. Healthcare, disease progress predictions, real estate like a price estimation, weather forecasting like a sale forecasting, and energy demand prediction. Okay, we will see the next one is the how supervised learning work and why we are step by step process we are using the supervised learning like the supervised learning how to use this step by step process. There are the five steps we will see in the supervised learning how to apply and how to detect the data for the future prediction. First of all, the supervised learning follow a structured process is not just about applying an algorithm. It involves several important steps that ensure the model learns properly and give a accurate prediction. The five main steps are first one is the data collection, second one is the data pre-processing, third one is the model training, third one is the model training, fourth one is the model evaluation, and fifth one is a prediction. Let's understand each step in the detail. Okay, first is a data collection. The first and the most important step in a collecting data. In supervised learning, we will need label data. This means each input X must have corresponding correct output. For example, house price prediction. Input like size, location, number of bedroom. Output is the house price. And it's in the spam detection, input is the email content, output spam and not spam. This quality and quantity of the data directly affect the models of the performance. If this data is too small and model may not learn properly. Poor quality prediction will be inaccurate. So good data collection is the foundation of the supervised learning. Data pre-processing. It is the raw data is usually a messy, cannot be directly used for the training. Used for the training, therefore we will must clean and prepare it. This process is called as a data pre-processing. It includes and several tasks handling. First, the handling a missing value. Sometimes the data contains missing entries. Example, each column has a empty values and salary field is missing. The solution remove rows with missing value, replace with mean, median or mode and use the advantage imputations technique. If the missing data is not handled, the model may give a more predicted wrong prediction. Encoding the categorical data. Machine learning model is understand the number or the text. Example, gender, male, female, city, Delhi, Mumbai, and Chennai, and we convert into a numerical forms like male zero, female one, or one hot coding is like this step is the initial for the proper modeling learning. In the data processing, the third one step is a feature scaling. Some features may have large value with other have small value. Example, age equals to 25 as salary equals to 50,000. Large differences in sale can affect the certain algorithm like KNN or SVM. We use a normalization and standardization. This ensure all the features contribute equally. Model training. After a pre-processing, we will see the third one is a model training. The first one is the model training. The algorithms learn pattern from a training data. After a pre-processing, the clean the data is split into training data or testing data. The training data it is usually 70 to the 80% or testing data is 20 to 30%. The training data is used to teach the model during the training. The model's algorithms learn patterns between X and Y. It adjusts the internal parameters, it means prediction error. For example, in a linear regression, it finds the baseline. In a classification, it finds the best boundary between classes. This stage is where actual learning happens. The fourth one is the model evaluation. The evaluate using a matrices like accuracy, precision, recall, and F1 and mean square error. After the training, we will must check how will modern perform. We test it using the testing dataset and different problem using the different. For a classification problem, the first one is accuracy. Correct prediction and total prediction. We are using the accuracy. The second one is a precision. How many predicted positive were actually correct? And the third one is the recall. How many actual positive were correctly predicted? The fourth one is the F1. F1 is a balance between precision and recall. These matrices are especially important in medical diagnosis and fraud detection. For a linear regression problems, we will see the fifth one MSE, mean square error. Average square difference between predicted and actual value. Lower MSE is the better model other matrices. RMSE is the R2 score. Evaluation help us understand is the model overfitting. It is the underfitting and does it generalize well. The fifth one is the prediction. Once the model performs well, it is ready for a real world use. Now new unseen input data is given. This model prediction is the output. Example, the predict loan approval, predict house price, predict this is this. This is the final objective of supervised learning. Complete flow of the summary, collect the label data, clean and process the data, and train the model. Evaluate the performance, use model for the prediction. Important concept of overfitting and underfitting. Overfitting means the model performs well on training data but poorly on a new data. Underfitting models fails to learn patterns properly. A good model balance both. There are the real world example. Let's take the spam detection. Collect 1,000 of label data, clean the text, convert numerical features, train classification algorithm, evaluated using accuracy, use model to filter new features. This entire pipeline response supervised learning in actions. Conclusion: supervised learning works through a structured pipeline. Data collection build the foundation. We will see the next one is like the advantages of supervised learning and disadvantages of the supervised learning. First one is the advantages of the supervised learning. High accuracy when enough label data is available. Okay. Supervised learning, one of the mostly wide used in a practical machine learning techniques. Has become very powerful in industries such as healthcare, finance, banking, e-commerce, and technology because of its reliability and structured learning process. High accuracy when enough label data is available. One of the biggest strengths of the supervised learning is highly accuracy. Since the model is trained using a label data, it already knows the correct answer during a training. It's learned directly from example. It adjusts itself to reduce a prediction error. The more highly accuracy quality label data we provide, the better in a model learn. The more accurate the prediction becomes. For example, in a medical diagnosis, if we provide 1,000 of label patients' record, the model can predict disease with high precision. In a spam detection, the large label email dataset improve filtering accuracy. However, this accuracy depends on data quality, data quantity, and proper preprocessing. The second one is a clear performance matrices. Another major advantages is the supervised learning has a well-defined evaluation method. Since we know that the correct output Y, we can easily compare, predict the output X versus actual output. This calculates the performance matrices such as the data we will spin and we will start it. Accuracy, precision, recall, and F1. Then the next one is the for regressions, mean square error, root mean square error, and R2 square. These matrices we will see a measurable result. This is a very important in real world applications like banking models. Test carefully before approving loans and in healthcare evaluation matrices help ensure patiently and safely. Because of the clear performance and measurement, supervised learning is easy to validation. Well understood, the next one is the linear regression, logistic regression, decision tree, support vector machines, k nearest neighbor, and random forest. These algorithms, having a strong mathematical foundation, are widely documentation, and we will see they have one proof performance in real world. It is easier to implementation them and implementation them It is easier to debug issue. There are the many libraries. It is easier to debug issues. There are many libraries available like scikit-learn and TensorFlow, etc. Because of the maturity and stability, supervised learning is often the first choice in machine learning projects. Easy to evaluate the result. Supervised learning is a model that we have seen. We are using this to use of the detected overfitting and detected the underfitting. Improve the model step by step. We will see that there is in a contract unsupervised learning does not have a label data, unstructured data and transport the evaluation of the data. Additional practical benefits is a strong generalized when properly trained and we will use for the data of the correction. Fraud detection, image recognition, there is the customer services, customer organization and all other the advantages. Customer churn prediction. Conclusion: highly accuracy with a sufficient label data, clear measurable performance, well understood stable algorithm, easy to understand. The next one is the disadvantages of the data. The disadvantages of the unsupervised learning. Okay. We will see in a machine learning the disadvantages like powerful and widely used of the supervised learning. It is not a perfect, is like every technology. It has a certain important rules, importance rules that we are seeing like the others one. It is a apply for the supervised learning like the important applying supervised learning in real world problems. We will use the required, first one is the required large label data sets. Large label data sets is the every input and the use of the data. Like the data, we are the model learn from the label data examples too small and inefficient. Okay. So for example, the image recognition. This is the thousand even words and the data we will use the like the data once we will using this. Okay. The third one is the data we have seen in this unsupervised learning. That is the data one we are using like image recognition, thousand of even millions of label data and have the data we have seen in the label data set. Okay. The data we have seen in the data sets is like that we are using the data not over the data sets but also the data values. That's why we are using like a data are not a data set but this the data values and this data values is not like for using of the label data sets. Label data can be expensive or time consuming. Human efforts, expert knowledge, time and financial research. For example, in a healthcare, doctor must label a medical report. Human must label object to in thousands of images and in sentiment analysis, people must manually read and classify text. This process can take months or years, cost a large amount of money and require domain expert. The third one is the risk of overfitting. Overfitting is a major problem in supervised learning. Overfitting happens when the models learn for the training data too well. It is a memorized pattern instead of the understanding general text. It performs well on training data but poorly on new data. For example, if a model is memorized exact house price index and learning the relationship between. The fourth one is the performance dependence on a data quality. Supervised learning heavily depends on the quality of the data, incomplete, noisy, biased, and incorrect labeled data. Applications of the supervised learning. In the applications, the medical diagnosis, face recognition, fraud detection, sentiment analysis, face recognition, and recommendation systems. For example, the companies like Google and Amazon are use a supervised learning in the search engines, recommendation system, and personalization. First is the medical diagnosis. The medical diagnosis we will see there are the lots of data we are used in a medical. They are using like the data for the patient's disease recognition. One of the most important applications detect the cancer from medical image, prediction diabetes risk, identify heart disease, and this system is assist doctor by providing faster diagnosis and reduce a human error support early detection. However, accuracy is extremely important in a healthcare application. Face recognition. Face recognition is the supervised learning to identify, verify a person. It is output. This next one is a fraud detection. Fraud detection is heavily depend on a supervised learning in a banking and finance. Input transaction detail fraud detection. Sentimental analysis for the using of the text data. This product is amazing. What service we are using the application of supervised learning. Real world the case study of example. First one is the spam email detection. Email text, spam, not spam. We are using a Navy bias logistic regression, accuracy, precision, and recall. Future scope. Deep learning is the integration, auto ML, transfer learning, explainable AI, and XAI. Real time prediction system. Real time prediction system. Real time prediction system we are using. Conclusion. Supervised learning, one of the most widely used machine learning techniques, predict a classification with the increasing availability of the data. Supervised learning is the continue to power intelligence system across the industries. We are seeing and this the data we are using the data sets on the supervised learning. This is the conclusion of the data sets, and we have seen all the data sets are we are needed. Supervised learning is one of the mostly used machine learning techniques. It play a critical and roles in a solving real problems. To predict and classification, the both are the increasing availability of the data